So hi everybody, my name is Abhiroop. I have been 19 years in the industry. I'll just switch on my video. Yeah, and I've been a chief technology officer in multiple companies, and I have been an early employee in one of the US-based conversational AI startups. So I've been in domain of AI from 2015 onwards, and working on NLP. Chat and voice bots, the traditional and other NLP domains, computer vision, and marketing AI. Yeah, and I've built products with AI. And currently, I'm a trainer in Gen AI space, Gen AI and cloud and data engineering. And we've been working across. I've been working across different customers, consulting as well. So I can share some of the insights, which I actually, based on the experience I got so far in the last few quarters, I would say, on especially working with large language models. Yeah. So let me just share my screen. Just give me a moment. Um, so I will take some pauses in between for questions. And if you have any other questions, you can just put in the chat also. So we'll go through the flow, and then in between, I can just stop a few times to answer the questions. Okay.
Before you start, Abhirup, we have a very quick poll to understand participants' familiarity. So
Sure.
let
Yeah.
me launch the poll for it. Yeah, for everyone.
Definitely. I will just stop sharing then.
So this is a poll. You have three questions here. So where are you from, and how many years of relevant or IT experience you have, and are you aware of Gen AI for business? Okay.
Okay. So we'll start. So today's agenda is we'll go through a bit of Gen AI fundamentals, then look at the business applications use cases, the current challenges with Gen AI, and how do you start your Gen AI skill building. Okay, especially if you're from the business side. Okay, not the technical side. So either you're business or you are kind of quasi technical. Okay, then how do you get started with Gen AI, and how do you kind of be ahead in the curve. Okay. Um, Now, so Gen AI is actually the branch of AI, okay, where it's about generation of content, okay, and it's creative content. It's open ended, which means obviously, the number of restrictions are less. Okay, obviously it's governed by the prompt, but or the kind of the query or the instructions which the user gives. So the data which or the content which is generated can be text, image, audio, code simulations and videos. In fact, synthetic data as well. If you have less data and you want to train your machine learning models, you need to create more data. You can actually use generative AI tools. Now, why it is very disruptive to the existing way of working and the existing jobs, right? Existing skill sets is a lot of this creative content so far had been created by humans. Okay, now machines are able to create this kind of content, ingesting humongous amounts of data and being able to do calculations and the generation much faster than humans can do. Okay, so the disruption is because of what humans were doing. This is a major thing which humans were doing. It's content creation, data generation. That's machines are doing now, and also it can do it at scale, much faster and more efficiently than humans, and they can work 24/7, right? So that's where the disruption comes from. Now, so generative AI. Now, I will just talk about the technology very high level. So Gen AI tools are based on large language models, which came from the domain of NLP transformers. You have diffusion models, which are for image and videos. Okay, so large language model is for text and code. Transformers, are the building blocks of large language models. So transformer architecture is kind of from the domain of natural language processing. Diffusion models are for image and videos. and variational autoencoders and generative adversarial networks. They're also kind of the technologies which form the backbone of generative AI. Okay. Now, the major revolution came in the field of generative AI when the large language models and the diffusion models came in a few years back. Okay, because they were transformative. Because here you have built extremely large models, machine learning models, okay, with billions of parameters, which have been trained on terabytes and petabytes and even more data. Okay, huge amounts of data. Okay, so there has been a lot of investment which went through in training and optimizing the models. Okay, and these models are available for any custom tasks, so I will come to that. But so far from a technology scope, this is these are the main technologies. If you see on this on the right side, on the left side you can see some of the kind of tasks. So large language models is one of the building blocks of generative AI. Okay, and here you have, if you look at the first task, machine learning is dash dash dash. It's, so it's a next word prediction. So you have this domain of language models where you do a next word prediction or a next sentence prediction, okay, or predicting the next set of paragraphs or group of sentences. Okay, so there's a prediction. It's a language model. The second one is a translation, where you translate from, let's say, English to kind of it might be a Spanish or some other language. Okay, so this is a translation problem. So you can do next word or next sentence prediction, which is language modeling. You can do a translation with LLMs. You can do, the third one is predict a response. What is machine learning? And you get a response. Okay, it's predicting response. Then you have the fourth one is classification, which is you have an email text. So it's a kind of bunch of text on an email, and you have to classify the spam or not a spam, right? So this is something which traditional machine learning models were able to do it. Okay, but now with large language models, okay, you can do it more efficiently. We'll come to why and how. Okay, the last one is scoring. Okay, so these are some of the kinds of natural language processing tasks which can be done with a large language model, which again comes from the domain of generative AI. Okay, so whenever you actually have generative AI task categories, so whenever you think about generative AI, you have to think in terms of three things. One is the generation of content, okay, which is a major part. But these large language models and diffusion models, okay, they can be used for classification also. Okay, so spam filter, for example, a email is spam or not spam. Okay, it's a classification problem. A third is a regression problem, wherein suppose you have to forecast the sales values of the next 12 months, right? So it's creating new data. Okay, you're doing creating predicted values, but these are numerical values. So you can use large language models or other generative AI techniques for regression also. In fact, for regression or forecasting, there is a new technology technique which has come. It's called time GPT, which is used for time series predictions. Okay, so you can see generative AI has been evolving rapidly, and a lot of new techniques and new use cases are coming also as part of Gen AI. Any questions so far?
Any
Okay.
questions, anybody? So if you are unable to talk, as I said, you can use the chat option, or else you can use the Q&A tab also for the questions.
Yeah. Okay. So now we'll come to the basic fundamentals, which is language model. Now I want to make it more semantic, more conceptual from a business point of view, not going into technology. So I'm keeping it very high level. Okay. Now a language model is actually, so if I look at the pre-large language models era, you had something called language models in the domain of natural language processing, where what happens is you use a language model to predict the next word or next sentence or next paragraph or groups of sentences. Okay, so here, given a sequence of words, you predict the next word. Very simple, right? The prediction is greater than the probability distribution of next word. Okay, so I will give you an example. So how are you doing? Okay, if let's say if you go to Google Mail, Gmail, there's autocomplete, right? Or there's an auto suggestion. Okay, so you say how are you doing, so it will suggest you some text, right? It will only suggest you one text. Okay, so what happens is here, if you look at, you are passing this to a language model. Okay, the language model, what it does is take the input as a sequence of words, and it predicts what can be the next word. So it has actually probabilities. Okay, so you see that the probability of, so today, now, at the moment, and these days, these are the four most probable outcomes. Okay, how are you doing, one of these four, right? But if you see, the language model is giving different probabilities to them. Okay, so the today has 0.95%, or let's say, so probability is a score between 0 to 1. So the score is 0.95 for today, so this is the highest probability. So how are you doing today is the highest probability. So today is the highest probability word, which the model picks up and recommends as part of the auto suggest. Okay, um, so whichever word has the highest probability will actually be proposed by the model automatically. So generate text, obviously you pass a sequence of words, calculate the probability, and declare the output with the highest probability score as the likely outcome. So how are you doing today? Okay, it's a very simple language model. Okay, which anybody from business should actually understand. This is how it works. Okay, now we come to the second one. Now what happens is, now these language models are not new. They were present from the last 70 years, more than 70 years. So what has changed now? The first thing has changed is size of sequence that the modern language model can use to predict the next word. So for example, um, if you look here, I'm just passing how are you doing. Okay, now let's say, imagine before this word, there are two pages, like we have five paragraphs. So imagine if you can pass on those five paragraphs, and then how are you doing also. Okay, so the model has a lot of context. So context is basically the words or the sentences coming before and after. Okay, so that sets the context. Okay, the context in with respect to the current kind of passage or the sentence, or kind of the story. Okay, so that context comes in. So when you have a context, you feed a context to a model, it can predict even more accurately what should come next. Okay, so here, because of the current innovations, you can actually feed a lot of context, text coming before, and sometimes a lot of text coming after also. But here in this case, because it's a sentence completion or a word completion, you are feeding the context as the words coming before this sentence, this phrase. Okay, so maybe you can feed in 200, 300, 1,000 words also. Okay, so that was not possible before. Okay, you would have not been able to input a very large sequence of words. Okay, earlier, because of the model's constraints in terms of memory and size. Yeah. um, so now the language models can predict, not at sentence level, but predict the word in the context of the phrase. Okay, the larger context. So this is the major change which has come. And modern LMs, large language models, they deal with tokens, not words. So token is kind of a piece of text which is usually three-fourths of a word. Okay, so when you look at ChatGPT and others, you usually come across this concept of tokens. Okay, so there's a maximum limit of tokens which you can pass into as a prompt into any large language model. Okay, these are something very fundamental conceptual, which are not much technical, but even a business guy needs to understand these things. Okay. Okay, now three innovations which is propelling the mainstream adoption of GenAI. So huge proliferation of data, different formats of data. Okay, you can unlock new and better insights. Okay, just 1 minute. I will just put on my headphone as well. Any questions so far?
We have one question in the chat, Abhiroop.
Okay. Um, just have a look. Okay. Um, See, LLMs usually work on the concept of prompting. Okay, so LLMs are trained with massive amounts of data. So imagine I create a LLM. So what I will do is I will scan through the all the data in the internet, all the data. Okay, so that will be my data set. See, there are multiple data sets like Common Crawl and others, which are humongous data, public data sets. Okay, so I use them. I use Wikipedia data. I use kind of the dictionaries. I use all the storybooks, okay, to train the model. Whichever are digitized, okay. Then I use all the data in the blogs, the internet websites, okay, YouTube, etc. Right. So I use all the content to train the models. Okay. Now the models are trained. Now what happens is once a model is trained, you can use it for different tasks. Okay. Now to work with the LLMs, you will usually use Python language. Okay. Now LLMs, how to use is see, mostly you have to follow the ML life cycle, but you take a LLM and you do something called a fine tuning. Fine tuning means you take a LLM which is already trained on large amounts of data, so it can understand natural language very well. Okay, it has very good general knowledge, general information about things. Okay, about the world. Okay, if you throw a name of a product, okay, let's say I would say iPhone 15, it will understand, okay, iPhone 15 is a kind of phone from Apple. Okay, it's the latest generation. So it has all this information, built in, because it's trained on so much of data, right? So you can take the model and actually you can fine tune. Fine tune means you train the model on your custom data, like your own business data, which is proprietary, and you can use it for your tasks. Okay. Now, what can be the tasks? Generation, regression, classification. Three kinds of tasks. Okay. Any kind of manipulation you have to do with in the large language model, you actually have to use Python mostly. Okay. Okay. So one is a huge amount of data which is available. You have scalable compute and storage, because even if you have to store the model, some models are like 800 GB as well. Okay. And if you have to actually train the model LLM on your custom data to fine tune for your tasks, right? Then the storage of the data also is very cheap. Okay, so compute is cheap, compute GPUs mostly, but nowadays there are large language models which actually are being able to use CPUs also. So that's where the innovation is going, from GPUs to CPUs, so that it's cheaper to actually use large language models. Okay, but the unit economics in terms of price to performance are quite favorable now. And then a lot of innovation and advancement going on in the field of AI. So because of these, the Gen AI has become more mainstream now than 5 years back. Okay, now, okay, so whenever you come to generative AI, there's a lot of jargons. Okay, now tokens is something we talked about very high level. That okay, we'll talk about prompts later on. And tokens is like a word or kind of three-fourth of a word, okay, or kind of set of few characters. Okay, so that's how LLMs, you give the input to the LLMs, you give in terms of tokens. Okay, now there's something called foundation models. Okay, now foundation model is nothing but see, LLM is a kind of foundation model. Okay, so foundation models are where you pre-train, you build a very large machine learning model which has billions of parameters. Okay, now parameters are the kind of variables which you can set to actually store the information in the kind of generative AI models. Okay, so, or rather the machine learning models. Okay, so you have a large machine learning model which is pre-trained on a vast amounts of data. Okay, and it results in a model which is intelligent, which has a lot of training done. It can be adapted to different tasks. Now what can be the tasks? You can say I want to do some document classification. Okay, I can do some kind of okay forecasting of sales, let's say. I can do some language translation, I can do some text summarization. Okay, I can kind of create a chat bot. can do machine reading comprehension, which means that question answering. So you give me a lot of PDFs, Word documents, maybe HTML files which has a lot of text, and then you can ask some questions, fact based and reasoning based, and the question answering app will be able to find the answers. Okay, and then there is a probability of the answers, obviously, but majority of the time, many of the times, the answers are quite pretty accurate if it's fact based. Okay, reasoning based again is a area where things are improving. Obviously, reasoning is always complex, but these generative AI models can also do reasoning. Okay. um, So traditional machine, now what's the difference between foundation model and traditional ML models? So if you have to, let's say, do a classification, let's say a email spam filter, you have to. So if I feed an email, the model can classify it's a spam or not a spam. Okay. Or the other example is, let's say in Amazon.com, there are a lot of feedback about customers, comments about products, right? So you have to classify into each of the comment into negative sentiment or positive sentiment. Okay, so that's an example of a classification model. Now, if you have to build a classification model with traditional machine learning methods, okay, you have to first train the data. So you have to collect a lot of data, and then let's say 10,000 emails or 10,000, 20,000 different reviews, right? You have to feed all the data, right? And to train the model, so it takes several days, a lot of compute power, a lot of cost, time. Okay, and then you have to train, then test and validate and optimize, right? That entire cycle is there. Now with foundation model, what you can do is a lot of that training process, right? Because training is not only training, but training starts with collecting the data, then looking at the data quality, improving the data quality. So there's a lot of work required in data pre-processing, okay, or improving the data quality or cleaning the data, right? So that entire data science process was involved in. Okay, now what happens? You can cut down that entire data science process, data collection, and kind of cleaning, transforming, processing, pre-processing the data, right? So that cycle is gone, and then also the training cycle is gone, right? Or it has reduced a lot. Okay, if not gone 100%. So what we can do is we can take a foundation model, which is a large model, which is already pre-trained. So either it's for image or videos, or it can be for text and code. Okay, and you can use it for your own set of tasks. For example, you can take a so large language models are foundation models usually. Okay, and you can take a LLM, let's say GPT-4, and you can say, okay, I will train it on my own HR policies. Okay, so you feed HR policy documents, and you say that, okay, now I will ask questions on the HR policies, and it should be able to answer. Okay, so the model has general information coming from, because it's trained on general, lot of general knowledge, and it has company specific information and terminology. So it can actually give you properly formatted answers. Okay, which seems to be like somebody, like a human being is giving you an answer, right? So that same way a machine can give you answer. Okay, that's because the foundation model is solely trained on general knowledge, so it knows how to give answer properly in a human way, and also it knows the specific details of your own custom business data, which is HR policies. Okay, so it can actually query HR policy documents and give you proper answers. Okay, so pre-training has been done on unlabeled data. So you have not labeled it; it's unsupervised. Yeah. Okay. So foundation models can be trained on terabytes or petabytes of data, hundreds of billions of parameters. So the parameters, actually, more the parameters, the more the kind of knowledge or intelligence or the information encoded in the or the training data which has been used for the foundation model. Okay, so if you have more parameters, then it's more intelligent in a way. The model is more intelligent, more capable. Okay. um, so usually you have three kinds of foundation models. Okay, so one is text to text model. So you input a text, you get a text out. Okay, an example is a language translation. Okay, so you input English text, a sentence, and you get a French or a Japanese or German. Okay, you specify I want a German translation, right? So you get that translation. So text input, text output. Okay, that's a large language model. Then you have text to image. You can say, hey, draw me an image of MacBook Air 2. Okay. uh, or kind of MacBook Pro. Okay, so the model will actually give you some sample images, create some images of MacBook, MacBook Pro. Okay, and it can give you three or four different colors of MacBook Pro. Okay, so that's text. You're giving a text instruction and you're getting the output as an image. Okay, and text to audio or video. You can say, hey, music composer, compose a music, right? Something like, or kind of create a video for XYZ. So that's kind of giving a text instruction to create a specific audio or video. Okay, so these are the kind of foundation models. We usually work with the large language models. Now, one innovation which is happening in the industry is convergence. So it's called multimodal large language models, where one large language model can understand text also, image and video, and other forms of data also. So you don't have to have different kinds of foundation models. Maybe in future, a few months down the line, you will have one foundation model which can process any kind of data, which can be text, audio, video, images, or any other numerical data also. Okay. So now, when you think about Gen AI, you think about technologies, large language models, diffusion models. Now, with multimodal large language models coming in slowly, diffusion models may not be required. Okay. Then you have generative AI. First thing you think about is foundation models, which are very large, massive models which are pre-trained. Now, those foundation models can be three types: text to text, text to image, image to text to audio, video. Right. So the text to text is a large language model. Okay, so LLMs is nothing but a foundation machine learning model, okay, which can understand and work with natural language. So it can work with text and code both. Okay, the software code. um, and some examples of web applications. So okay, so ChatGPT is a web application where it has a kind of a web interface and a mobile interface, and in the backend, it has there's this large language model families, GPT-4 and GPT 3.5. And when you give instructions to the ChatGPT as prompts, then they interact with they give the inputs to these large language models and then get the output back. Okay. Similarly, Google Bard also has a web UI, and the backend is a large language model. Okay, so this is, you can see, natural language processing, which is about understanding and generation, analyzing, understanding, generation of text. Okay, so under that you have language model, and under that you have large language model. Okay. Um, So ChatGPT interacts with, okay, so web and mobile, and ChatGPT also gives you a API which developers can use. Okay, so you can actually consume the output of the ChatGPT into your applications using an API as well. Some of the examples of large language models. So you have open source, closed source, both. Open source models are a bit cheaper. They are more explainable. Actually, understand the source code. You know how it works, but more than you understand the closed source. Closed source are more opaque. Okay, the transparency is missing there. Obviously, there is explainability built in, but explainability is usually more in open source, and cost factor also. Cost wise, also open source models are more favorable. Okay, so there's a debate going on between should we use open source or closed source. Both has pros and cons. Okay, but usually the trend is towards favoring more of open source. So enterprises actually want to use more of open source LLMs. Llama 2 and Mistral 7B and Falcon. These are the top three open source LLMs. Okay, so today if you have to work with a open source LLM, you have to actually either use a Mistral 7B or a Llama 2. Okay, in future there may be something else. Okay, but these are the leading ones in the top 4 or 5 right now in the market. Okay, but the kind of the rankings keep changing on every week or 2 weeks. Okay, so some new model will come very soon, which will kind of score over the Mistral 7B or the Llama 2. Okay, so that's the pace of innovation. Sometimes it's good, sometimes it's bad that innovation is so fast. Okay, so what's the business value of GenAI? Now, which are GenAI? When you think of GenAI, think from a framework that you can use it for generation of content, classification, and regression. Okay, In terms of business value, you can kind of use this framework. Okay, there are three things you can do. Any business use case of GenAI should fall under these three categories. Okay, now one is improve the personal and team productivity and performance. Okay, innovate faster, better, so you're more competitive than your competitors, and reduce the cost and complexity of operation by automating and speeding up tasks. Okay, part of some of these are interrelated as well, but this is a kind of framework if you think about when you're exploring or kind of trying to discover what can be the use cases for GenAI. Okay, so basically use GenAI to augment human creativity and intelligence. Okay, instead of replacing jobs, you actually have to think about how do you augment the humans. Okay, make them kind of cyborgs in a way. Okay, make them more powerful and stronger, better performing. Okay, so it is said that people who can use GenAI tools better, they have more knowledge and experience on GenAI, will actually replace those who are laggards or who are late into learning GenAI, right? So that's where the things, the debate is going now. Okay, so it's not that GenAI will replace human job, but it's obviously it's going to do a lot of automation. But people who actually working with GenAI and are much faster to learn and embrace in their work, they will be scoring over people, and they other people, and they kind of will grow in the careers. Okay, so prompt engineering. You guys might have obviously used ChatGPT. So prompt engineering all about how do you craft effective inputs so that you get the best output from the large language model. Okay, now we can ask a question in different ways. What is the best way to if you frame it in different ways, right? If you ask a question to the large language model in five different ways, okay, you might get five different outputs. So you have to frame it in a way that you get the best output. Okay, and that's all of prompt engineering all about. So give a prompt to a large language model, and the completion happens, which is the response you get from the LM. And the response quality will obviously depend on how you've given the prompt. Okay, so there's an entire kind of I would say a different topic on on prompt engineering, how to actually craft effective prompts, and that's kind of a few hours session which we have part of our GenAI for business programs. Okay. So this is an example of a prompt to so two kinds of LLMs. So one is which are the LLMs which are part of the Chat GPT, and LLM which is part of Google Bard. Okay, which is Palm 2, Google Palm 2. Okay, so you ask them to generate a list of distinct characters. Okay, so with Google Bard you get this output. So there are multiple distinct characters, but here you see the image also, and you see the way it is giving the output. It's a kind of form. It is giving the response in a well formatted way. But if you look at Chat GPT-4, which is in Chat GPT, the plus version, Chat GPT plus version, the paid version, it'll give you a list like this. Okay, so different. You might get a bit different outputs. You might get a more formatted output. So you can try out the same prompt in different LMs. With different LMs, you might get a little bit of different output. Okay. Now, there are a lot of generative AI tools and products. If you look at the right side, Sequoia Capital's generative AI landscape, it is still evolving, obviously, but it's different data types. So generative AI for text, code, image, speech, video, 3D, others. Okay, and there are kind of use case categories given. So this you can actually go through it later on. There are some tools, the Y Combinator winter batch, and these are some of the products which are using GenAI techniques in their use cases. Okay, so you will have this slide, so you can actually look at some of these companies are doing. Okay, this is another slide where it's from Sequoia Capital, and there are a lot of products which use GenAI or GenAI first products, but these are some of the examples. Okay. Now, use cases. Okay, so Gen AI use cases are usually, the major ones which are coming out are in customer service, marketing, sales, software engineering, and R&D. So there will be a lot of automation of tasks, and there will be reduction in the number of, I would say, jobs required to do the same kind of work which is done today. So there will be less manpower required. Okay, because there's more automation, more use cases coming in these areas. Okay. Um, Now customer service. So I've put down some of the uh, specific use cases. You can go through it later on. But I would say here, research and development, I've actually included software development as well. So software code generation, code debugging, test case generation, testing automation, right? These are some of the kind of areas where there's a lot of disruptive potential. Okay, so there's a lot of automation of developers, software engineers, which can happen. Okay, automation, in fact, in the kind of tasks. Okay, so now obviously you might be able to build more complex products and have them, with better quality. Okay, and more reliability as well, with lesser number of people and lesser cost, and even faster. Okay. Sales and marketing in particular is a kind of one of the leading areas, uh, where you see more use cases on GenAI. Okay. I have not mentioned few more areas which are coming up, like SEO, also search engine optimization also is an area where there are tools coming up for automating using GenAI. Okay, so customer service is one of the top areas where you can actually automate a lot of tasks which human customer service agent can do. The previous generation, few years back, you mostly had FAQ bots. Today, the bots, chatbots, are more intelligent to do end-to-end resolutions as well. Okay. Yeah. Similarly, for industries, I've just given two industries, but there are many other industries where you can actually use GenAI. Now, even if you look at customer loan approval, you actually could have used the traditional ML techniques, but now you can recast or reframe some of the traditional ML problems as GenAI, generative AI problems, right? And then you can use the GenAI tools. Okay. I will not go into details of it, but two customers. There are many customers who are using, generative techniques for different use cases. I will give you a few more examples apart from this. So Stitch Fix is apparel retailer, and they are using GenAI tools to sift through a lot of customer feedback to understand what are the trends, what they like, what they don't like. Okay, and based on that data, they are kind of feeding it to another model which can actually create new product designs which takes the feedback of the customer, the positive and negative. Okay, based on that, how we're creating products, new products. Okay, using a combination of different kinds of GenAI techniques. So it can be large language models, diffusion models. Okay, so GPT-3 is based on large language model. DALL-E is based on its kind of text to image. So it's based on diffusion models. Okay. Now Carvana, uh, so they're doing ads hyper personalization. So based on the specific data of a customer or a lead, okay, they are kind of they can create new kinds of ads and target or tailor and obviously position to a specific customer or lead. Okay, so this can be a pretty big area of innovation, which was not so easy before the current set of GenAI tools given. Okay. Others, Morgan Stanley, they have about 16,000 advisors. Okay, for different financial products. They actually collected all their information. Okay, kind of the recommendation, market research, etc., into one place, and then put a kind of a LLM layer on top of it and a chatbot. Okay, which is kind of a co-pilot or assistant for the advisors, and which can actually help them craft better recommendations or give better insights or consulting to their customers. Same way, McKinsey also have taken all a lot of their existing data, existing knowledge repositories, assets. Okay, they have huge amounts of assets, right? Consulting work which they have done, consulting knowledge repositories. It's very hard for people to go through a lot of those in very limited time. So they have aggregated everything, all of those, and created a co-pilot and a kind of a large language model layer. Okay, where you can interact with this humongous information with chat and with chat, in fact, okay, with human language, human natural language, and you get insights which you can use in your consulting work. Okay. So that's a very common use case, that your knowledge repositories, humongous knowledge repositories, and you combine with external data also, okay, dynamic external data, and then how do you create kind of a question answering system which can be kind of a co-pilot or assistant to your consultants or advisors or employees, yeah, and help them give better service or better suggestions or recommendations to their customers. So challenges of LLMs. Okay, so explainability of response of output. Okay, so what happens if you ask LLM that please describe what happened in the French Revolution? Okay, it will give you all the kind of a big few sentences or few paras, but you don't you don't know if it's correct or not. How do you explain, right? What's the source? Okay, so from what source the information was derived by the LLM, right? So that is not clear. So that's one drawback. Okay, how do you verify the authenticity or the veracity of the kind of output, right? The quality of the output, right? The second is information in LLM can be outdated. So what happens is it's not trained on a daily basis, right? It was trained, for example, ChatGPT 3.5 was trained till September 2021, right? The GPT 3.5. Okay, so what happens? How do you incorporate information which came after that period, right? After that date. So that's another challenge. Now, cost of using LLMs is high. It is going down progressively, but still it's high right now. And biased stereotypes. So gender and religion and color-based, biases are there because of the training data. Some training data introduce biases and stereotypes in the model response in the model. So when the model gives a response, it can kind of give a biased response as well. So let's see how do we address few of them. I'll give some examples. So there are different techniques in generative AI, but there's one technique called retrieval augmented generation. Okay, and I will give you the business concept of that. So let's say you ask an LLM, in our solar system, which planet has the most number of moons? Okay, now LM answers confidently. Okay, Jupiter with 88 moons. Now, one of the challenges which I also would like to highlight is hallucination. Okay, so the model will tell you something confidently, but it is a wrong answer. But the model is very confident. It will give you answer. Okay, so let's say for this question, it will give you answer Jupiter with 88 moons. So it will be very confident. Okay, but what happens? The correct answer is Saturn with 146 moons. Okay, now the answer. So first thing, what happens? Let's say this model was trained up to September 2021. Okay, after that, the scientists discovered that there were few more moons in Saturn. So Saturn has the highest number of moons, right? So maybe till September 2021, Jupiter was the answer. After that, it has become Saturn, right? After that, at some point, okay. So that was not captured in the LLM, right? So it gave a wrong answer and gave it very confidently, and then you take the wrong answer, and if you take some decisions on that, it's bad actually. Okay, so businesses cannot it's very harmful for businesses in particular if they have to act on incorrect information. So hallucinations is a kind of a very common challenge with LLMs, and there are many techniques which have come to address that. Okay. um, Another example I can say is, did as Silicon Valley Bank collapse? Okay, he says no, it didn't collapse. Okay, now you ask this question in August, and let's say the model was trained till September 2021 or 22. Okay, so it will give you this wrong answer. Okay, because time sensitive information. Okay, so how do you improve the challenge? So let's look at this answer. Jupiter, it should be Saturn, but Jupiter was the answer given, wrong answer given. So what do you do, right? So you add retrieval augmented generation RAG. So what happens is, you see on the right side, there's a question you ask to the LLM. It first goes to the retriever. Retriever will actually look at the external data. store. So there is a data store, okay, from where it will retrieve the latest and the dynamic data, the latest data. Okay, and it can be dynamic data also, and then it will combine it. It will prompt the LLM and it will get the answer. Okay, so relying on the LLM's answer only, you add a content store, okay, which can be open like the internet or closed like any collection of documents or policies. Okay, the LLM talks to the content store and can retrieve information relevant to the user's query. Okay, so all so you are not restricted to the only the output of the LLM. You rather use the latest information which is available on the internet or in your kind of custom data. Okay, now it might happen that for the question the user asked, there is no data in the external data store. That can also happen. Okay, but there are a lot of instances where it will happen that okay, whatever is asked, okay, the external data store has the latest data about it. Okay, and so it can give you the most current answer. Okay, which the LLM might give you a wrong answer, but the external data source can give you the right answer. Okay, so answer is not Jupyter but Saturn, because now let's say the external data store you have connected to a data store. Okay, so when you say okay, which planet has the most number of moon, it kind of gets the data from the external data source, then it checks for the LLM also and see which is the most current, and it gives you the answer accordingly. Okay, so if new info comes up, no need to retrain the model. Now, retraining the model with new data is very costly. Okay, so instead of retraining, you actually can connect to the external data source and pull the latest information. Okay, and also the LLM is now instructed uh, to actually give you evidence in terms of it tracks the okay, it actually can tag the primary data source. So for example, here if it's external data store in a RAG setup, and this data store is a NASA's database, okay, it can say okay, Saturn is the answer. Okay, and I'm quoting this answer because I'm referring to the NASA data store. Okay, so now if you give a citation or a reference, it is easier for the user to trust the answer. So it makes the LM less likely to hallucinate. Okay. Also, if the user's question cannot be reliably answered based on data store and the LLM, then the model should say, I don't know, instead of making up an answer that you believe but it's not true. Okay. So hallucination is all about that. Hallucination is, the model will give you a wrong answer. If it doesn't know the answer, it should say, no, I don't know, rather than giving a wrong answer. But it will confidently give you a wrong answer also many times. So that way it erodes the trust because you don't know which answer is correct, which answer is wrong. So there are a lot of false positives and false negatives which come in the system, right? Or rather, there are a lot of false positives which actually you see because the answer is coming in, you don't know whether it's 100% correct or there is a flaw in the answer. Okay, but with RAG, this is one strategy to actually improve the quality of your output and make sure the hallucinations are reduced, if not completely removed. Any questions so far?
Yes, Abhiroop, we have some questions in the chat and Q&A.
Yeah. Okay. So API connected to GenAI. See what happens is now let's say so GenAI, you have the large language models for language, for natural language and text, sorry, text and code, and you have the diffusion models for image and videos. Okay. Now, so these are kind of pre-trained foundation models. Okay, LLMs and diffusion models. Okay. Now, if you want to use the foundation models, okay, you have a way to use it through an app like ChatGPT or Google Bard. Okay, if you want image, right, text to image, or kind of image to image, so those kind of models, you can go to stability.ai or Mid Journey. Okay, so I would just put it here, stability, okay, or Mid Journey, right? So they are for videos and images. Okay, so that is one way that you have a web application, and using web application you can interact with the with the models. The other way is through APIs. So OpenAI has the GPT 3.5 and GPT 4. LLMs. Okay, so you can consume the output response of LLM using APIs. Okay, and pay per API call. Okay, so it's usage-based pricing. So no upfront cost. The more number of API hits you have, API calls, you pay according to that. Okay, so this is more of a awareness session. Demos I could have given you ChatGPT and few others, but it is kind of very short session, so we kept it like this. Uh, Sentiment we're drawing. Yeah, see, basically you have to do a model governance, and you have to build a layer. So you have to basically define some business rules. Look on what's the sensitive content, okay, which you don't want to expose. So so basically think about it. You give a prompt, okay. The prompt is an instruction to the LLM. So instruction goes to the LLM, and from the LLM you get an output, a response. Now you don't display this output to the user, or you don't kind of fetch it in the application directly. First, let it go through a filter, okay, a kind of one more layer, staging layer, where you say that okay, I will put a governance layer. Okay, so I will first filter out the content, the response, seeing that is there any sensitive information, is there any bias. If any bias or insensitive information is there, I have to kind of curtail it or mask it or take it out. Okay, and so I can kind of uh, transform or change the content or kind of enrich the content and then display it to the user or in the application, to the, fetch it in the application. Okay, so you have to put some middle layers for sensitive content. Leveraging AI tools for rapidly. Okay, more accurate the context at hand. Okay, so you're getting user guides. So have you done any kind of training? See, basically you have to train. So there are two things you have to do. Okay, one is you have to give the prompts very efficiently so that you can get the best output. The second thing is you have to train this AI tool on your custom data, which is the the user guides you guys already have, the SOPs you already have. Okay, so use this as training data, and fine tune means training on your custom data, right? Fine tune the AI tool. Okay, train them on your custom data so that it can generate um, it can generate sorry it can actually generate user guides and SOPs which are very similar to your data. Okay, so prompt engineering and fine tuning on your custom user guides and SOPs is something which you can try out.
Yes, we have one question in the Q&A tab also.
Okay, one day. See, I would say, LLMs. Now, think about LLMs as foundation models. So you don't have to build from scratch LLMs because it's very costly. It costs you millions of dollars to train, source the data, clean it, okay, ingest it into the model, train it, and it takes months to train. Okay, so that kind of laborious task is gone now with large language models. Okay, so you now get, so the foundation models you get, they are pre-trained. So large language model is a kind of foundation model, text to text. Okay, so you don't have to build the model, but everybody needs to understand learn machine learning. Even when we so we train both business and tech professionals. Even go to business and say that, so it's a finance guy, right? And he's they have, the company wants to see how do we use AI for for finance processes and data, right? So if that business person doesn't understand the basics of how a neural network works, okay, how a model training works, what is supervised learning, unsupervised learning, okay, what is weights and biases. Okay, how the forward propagation and the backward propagation neural network works. These are very basic things. Okay, so everybody should know. So if the business knows, they can actually be more confident in terms of discovering new use cases. Okay, and also when they work with the technical guys, they will have less friction because both understand how these how AI works. Okay, though the business guy doesn't do coding, but it at least conceptually understand things. Okay, so I would say everybody, software industry, even if a software developer, you need to understand AI very well. Okay, now you will be using AI tools for code generation, code debugging, okay, testing automation, right? So those tools you will be using, security testing as well. But many times you have to actually use the LLMs to develop applications. So I would say everybody should learn AI because a lot of your coding tasks will get automated. Okay, so just knowing coding is not enough. In fact, you know coding, you can generate a lot of code. You can go through it, review it, and kind of check it into your repository, code repository, right? So what you used to do in 10 days, you can do in 2 days also now, because a lot of code generation can be done by the tools, and you have to just check, review the code, debug it, test it, and then kind of check in the repository, source code repository. Okay, so what else you will do, right? If you have less number of things to do, so you will kind of learn more of AI, you'll work more with AI, and actually you will see where you can use AI in your day-to-day work as well in different ways, apart from just using the code generation tools. Okay, um, so I will actually go into this very quickly. So what we suggest now, this is more for people who are business or quasi business. Okay, who are kind of maybe work with engineers, technical software engineers, architects, but they are not doing hands-on every day, right? So for them, so we are kind of have a generative AI for business series of bootcamps. Okay, for 11 domains. So going through that, because we actually talk about the things, or teach the things which the business guys need to understand, which also starts with basic understanding of natural language processing, basic understanding of computer vision, basic understanding of neural networks. Okay, and how they work, and what are the terminologies. Okay, not going much into technical, and then showing how to build a chatbot. Okay, without code. So you understand how a chatbot works, how intent recognition, named entity recognition, all those things work, right? So how to fine tune the NLP engines, right? How NLP engine works. So fundamentally, every business guy has to understand these aspects. Okay, so that's something we start with. We go into prompt engineering and we go into the specifics of their use cases. Okay, and we also look at case studies of how different customers are using GenAI, in their kind of business process and data. And we also talk about, we kind of do, have you do hands-on on the generative AI tools. Okay, chat gpt, google bar, and many others. Okay, so we have tools which are very specific to your industry or domain. Okay, the second thing we say is, obviously, you find ways to start using the concepts in your workplace. Okay, find at least one or two use cases where you can daily use, daily, weekly, you can start using whatever you have learned. Okay, and use more of the GenAI tools. Um so this is what we have, about 24-hour duration boot camps. This is kind of level one, and obviously things are evolving, right? So we'll come with level two as well, where we have more use cases, more tools, as the Gen AI industry kind of evolves further. So it's for senior business leaders. How so how, when they're working with their customers and for the internal business strategy and with their teams, right? How do you kind of use Gen AI to be ahead of the curve? Okay, it is for finance professionals, for marketing, HR, and admin. So these are some of the programs we have, 24-hour programs. It's been done within a week, or 2 weeks as well. So these are some of the key jargons, and these are something which even the business guys needs to understand if they have to work with AI, right? So, for example, RAG, we are not going into the code level of RAG. We are saying that, okay, how do you kind of take care of hallucinations, or how you can kind of embed your own custom data without, in a more cost-effective and faster way. Okay, You have reinforcement learning with human feedback. You have supervised and supervised. So some of these are the things which we actually talk about. Word embeddings. Now, one thing you understand is these foundation models, generative AI techniques, right? They work on the concept of okay, uh, numerical data. Okay, so if you have a word, if you have text, if you have code, you have video, you have image, you have audio. The machine learning model, okay, doesn't understand this. They only understand numerical data, vector data. So you have to convert all of this data, text, image, video, everything into vector form. Okay, one dimensional arrays. Okay, and then the vectors will represent each of these. Let's say, for example, the words in a three-dimensional or four-dimensional or n-dimensional space, right? So these are some of the very basic concepts which even business needs to understand, right? And this is what we also teach. So tokens is very important. Tokens, basically, when you talk to LLMs, we actually pass tokens. So every LLM has a kind of context window. They have a maximum limit of tokens which they can take as part of a prompt, and a maximum amount of tokens which they can throw back as a in a response. Okay, so it's kind of controls the cost of using the LLM. Otherwise, you can kind of feed 20,000 words, okay, into the LLM and get output of 50,000 words, right? It's kind of very high cost in that case. Okay, so these tokens actually are in a way restrictions as well. So these are some of the things which we teach. We teach many other things, but these things you will actually be understanding pretty well. Okay, and this will help you work, as a business guy also, and when you work with the technical guys. Okay. So any other questions? So let me ask, any of you are working in business consulting, more on the business side right now, or all of you are kind of coming from a tech domain in a way? Yeah. Sorry, it's a question. I mean, if anybody can comment. Yeah. Yeah. Okay. Product management, fine. So a lot of use cases of in product management. In fact, the slide which I showed you, um, this one, right? Every product manager needs to know these things. Okay, if they are doing building something with the data and AI. Okay, now there's a lot of AI machine learning being used in products, so the product manager also has to understand this very well. So it's a must have to actually do kind of understand Gen AI in general very well if you are going into product management, if you want to go into product management. Yeah. um, yeah, so basically, we also coming up with Gen AI for product managers. So there are many tools for that as well. So I would say you need to understand Gen AI pretty well, because a lot of products nowadays are built using AI tools and techniques. And you also can do things like, for example, in product design, right? You can use a lot of AI, generative AI. So let's say you want to build a mobile app. Okay, I can feed the designs of maybe screenshots of let's say we are a food delivery app, right? In India we have Swiggy, and in the US we have, let's say, um, uh, Uber Eats, right? So if I feed you some of the screenshots, okay, design screenshots of the mobile app screens of Swiggy and Uber Eats, okay, or Grubhub, okay, and you ask the model to actually give you a design of a new food delivery app. Okay, so that's a example of a use case where you can use generative AI for product design. Okay, so instead of actually having a UX designer all the time, you can actually generate those designs using GenAI. or obviously even the designer can be more productive because they can generate a lot of the designs using GenAI techniques, tools, and they can further modify the designs as per their needs. But they at least get the design kind of recommendations, right? So 4 or 5 different ways of design, and they can choose from there. Yeah. Also for your analytics, you can use a lot of GenAI. You can actually ask natural language questions on your customer data, product data. So that's another area, product analytics, where you can actually get a lot of advantage using GenAI. Okay, so I'll just wait 2 more minutes. If you have any other questions, you can answer. And in general, if we want to discuss about your very specific requirements on GenAI training or upskilling, then I can also answer that. We can talk about your specific scenario and um, how you are envisioning GenAI to help you in your career. So we can talk about that as well. Okay. So if there are no questions, Swami, I'm just handing over to you. If you have any updates or comments, you can make. Okay. Where do you find cost of using the LM models? Okay. So what happens is, so let's say if you go to, okay, so you can go to the pricing page. Most of the LMs will have a pricing page. So they will talk about the cost and pricing and the pricing metrics. Okay. So here GPT-4, you can actually see the pricing metrics per 1,000 tokens. The model takes input as prompts, right? So per 1,000 tokens, it charges this much, and if it gives the output, this is the charges. Okay, so you can actually look at. Okay, you have to just read a bit because the pricing keeps changing. Sometimes it's a bit complicated at times. So this pricing is a bit different than if you go to Google to pricing. Okay, so pricing. Now this is the pricing for image generation in Google. Um, for text generation, you have the price per 1,000 characters. Now this is not token, this characters. Okay, so the pricing metric in ChatGPT is tokens. Here it's giving in terms of characters. Now one token can be set of few characters, 3, 4, 5, 6 characters also. Okay, so here it is more simpler pricing. It's based on number of characters. Okay, so you can actually look at the pricing metrics. It's a bit complicated the way the different pricing metrics are there, but you can kind of go to the pricing page of each LLM and know how the pricing works. But in OpenAI, if you make an API call to GPT 3.5, the older one, not the GPT 4, it's around 38 cents. Yeah. The price will eventually come down further. So that's where the innovation, a lot of innovation happening in Silicon Valley on how to reduce the cost of serving the LLMs, or cost of using the LLMs. Okay, so eventually the price will come down drastically. Okay.
Any other questions? If you have anything, you can ask now. The floor is open for you. And yeah, if there are no questions coming in, I think we are good to end the session here. We are planning more sessions with Abhiroop in the coming months. Please visit our KnowledgeHut website and please get registered. Also, you can get connected with Abhiroop on LinkedIn also. Abhiroop, if you can share your LinkedIn ID here so people
Sure.
can connect with you on LinkedIn.
You can just click on this link and send me a request.
Yes.
Yeah.
Thank you, Abhiroop. It
Okay.
was really a very amazing session. Thank you, everyone, for joining the session as well. And hope to see you all in the next sessions. Yeah. Thank you, everyone.